on two topics. One you're going to be very familiar with, and the other is something we need to get really nailed down before we go to solving equations. So exponents is repeated multiplication. It's just a way to write when you're multiplying a number times itself over and over and over again. And we're also going to be talking about orders of operations. But these all come into play when we have what is called an expression. And one of the things that my students in Algebra 2 continue to mix up is the difference between an equation and an expression. And this causes issues and continues to cause issues even into their junior year, senior year. So an expression is just a combination of numbers, variables, and symbols. It can be parentheses, it can be add, subtract, multiply, divide, it can be exponents. But the key part is if you have an expression, there is no equal sign. If you have an equal sign, you have an equation. If you have an expression, there is no equal sign. So a lot of people see an expression and they try and solve something. Well, that's impossible. You can't solve something if there's no equal sign. So expressions can be simplified, whereas equations are solved. So that's how you differentiate between an expression and an equation. So today we're going to be focusing on expressions. And expressions, you evaluate expressions. So to evaluate means to make something as simple as possible. So in this case, if there are no variables, that means it comes down to just being one number. And then when we get to variables being there, we're going to make it so that you've combined all like terms and it is as simple as possible. So this is where we are going to follow the orders of operations and make it into exactly one number. So when we evaluate, we want to first follow our grouping symbols, which in this case are our absolute value signs. So our absolute value signs, we're going to do what's in there first. So initially, we're going to do the 3 minus 4, which we know is -1. So we have the absolute value of -1 minus the absolute value of 5 minus 9, which is -4. So that was our first step in evaluating, is doing what was in, sorry, I'm blocking, what was in parentheses first. These aren't actually parentheses, but they're absolute value signs, but they behave the same way. What is the absolute value of -1, Brendan J? 1. And then what's the absolute value of -4, still Brendan? 4, and then what do I get at that? -3. Now notice I have added an equal sign, but there wasn't an equal sign to begin with. So this is an expression, and I have evaluated the expression. That means I've got it as simple as possible. So in order, we did the grouping symbols first. So we did what was inside of those. Those are the absolute value signs. We did the absolute value, and then we subtracted. If we did it in a separate order, you'd get a different answer. So you can't do it in a separate order. You have to follow the correct order. Questions on that? Now, we know that an exponent means you have repeated multiplication. So if you take a times itself n times, we call that a to the n power. And in terms of vocabulary, a is called the base of that exponential expression, and n is called the exponent. And we're going to spend some time at the middle of second semester doing all sorts of exponential laws. But at this point, we just need to know which is the base. The base is the regular number, and how many times that number is multiplied by itself is the exponent. At this point, we're going to focus on exponents being positive whole numbers, but we're going to get to the point where the exponents will be negative, they're going to be 0, they're going to be fractions. But right now, we'll focus on them being positive whole numbers, because that will make more sense at first. And that's why we're focusing on counting numbers, which start with 1. So we know if we have 6 being multiplied times itself 5 times over, we write it as 6 to the 5th. One thing to keep in mind when you have a negative base, you're going to want to write it as -3 to the 4th. See, parentheses around the negative is going to be essential. And the reason why that is true is because if I ask you to do this, -3 to the 4th, the answer is actually different. The first one says take -3 times itself 4 times over. -3 times -3 times -3 times -3. That's -3 to the 4th. This actually means -3 times 3 times 3 times 3. So if you don't put a parentheses around it, it means something different. So you do need to be careful as to using parentheses with negative bases. So -3 to the 4th means that, and this is actually -81, -3 to the 4th, taking a negative base, that's +81. So that's why it's very important to know what you mean here. Do you have a question? On top, I could write 6 to the 5th or 6 to the 5th. They're both the same thing. These are equal to each other. So the parentheses really is kind of useless. Any questions on that? So that's exponentials and bases. So if I were to evaluate -10 to the 4th, taking any 10 to a power, there's a little trick with that. You write the 1 down, and then the exponent is the number of zeros there are. So if there are 10 to the 4th, that means there's going to be 4 zeros. So that's the trick with powers of 10. Does anyone know if it's going to end up being -10,000 or +10,000, Jaleesa? Positive. Now, how did you know it was positive? Okay.
And then you take the first two, make it positive, and then it's just
Good. So if you write it all out, you can group them. This is 100. This is 100. So when you multiply negative times a negative, you get a positive. Another negative times a negative, you get a positive. And then you have all positives. So if you have a negative to an even power, you're going to have all those negatives cancel out. Questions on that? How about -5 cubed? What is that evaluated? Brennan? Like, what's the answer?
Oh.
How's it written out? Good job. Okay, so this is negative, and then 5 times 5 times 5, because you don't have a parentheses around the -5.
Oh.
Okay, and Nate, you have an answer?
It's -125.
Good. -125. All right, so this is called expanded form, when you write it all out. And then it's -125. And it actually, I think I heard this in the audience, that it would have been the same if you had it like that, that's true. Because -5 times -5 is 25, and 25 times -5 is also -125. So sometimes it works out, other times it doesn't. It all depends on whether the exponent is odd or even. But the expanded form varies depending on if you have the parentheses. All right. Now, what would I do first here?
You change 8 to -3.
Okay. You want to change it to plus the negative, and then what would you do?
And then it would be -5 plus -8
So I think if that were with x's and y's, or variables, you do that. But since these are just numbers and they're in parentheses, you can just do that math. So what would you get in there? So one's positive, one's negative. Oh, that's a good question. So because the negative's on the outside, all you have to worry about is what is on the inside. So you have the 5 plus -8. -3, good. So, order of operations, you do what's in parentheses first. Now, do we do the exponent, or do we apply the negative on the outside? What is next? Davian? Exponent, good. So what do you get when you do the exponent, Davian? Okay, -3 times -3 is 9.
And then you gotta subtract the subtract. I mean the negative.
Beautiful. Yeah, so it's a -9. All right, so you take the -3 to the square and you get 9, and then that negative comes on the outside, comes along for the rest. Lisa.
So, I use 5 minus 8 before, right?
Yep.
Do you always have to do that? Like, they did it twice, and then
It doesn't matter. You can either do 5 minus 8 and get -3, or 5 plus -8.
okay, so you never like mark it wrong if you did right?
It doesn't, as long as you're getting -3, it doesn't matter to me. Okay. Other questions? Okay, so the orders of operations I've already been referencing, but we've learned PEMDAS, or please excuse my dear Aunt Sally. Did anyone else learn other things? PEMDAS, please excuse my dear Aunt Sally. Anyone else have another one? But what it is grouping symbols. In this case, it stands for parentheses, but it could be parentheses, it could be brackets, it could be absolute value. There's so many different things that it could be. Actually, not those. Yeah, it could be those. So there are many different grouping symbols. That's why parentheses technically isn't an all-inclusive term. But then we go to exponents left to right. Multiply and divide left to right, and then add and subtract left to right. This left to right is very important, because if you think that multiply becomes before divide, you're going to get the answer wrong. Multiply and divide are the same. They are mathematically equivalent in terms of their power. So you just do those operations left to right as you do add and subtract left to right. And a lot of times, people post onto Facebook and are like, what's the answer? And then they're like, how do you get that? And it's like, oh, just I know what this means. But the general population doesn't know how to do this. And a lot of them get it wrong, that multiplication and division you do at the same time left to right. That's a big one people mess up, and the adding and subtracting left to right. All right, so how about 2 cubed times 3 squared? Isaac, what would you do first? Not bring up the typewriter. Okay, so you would do the exponents. So what would you get for this one? 8 You're doing the exponents left to right. What's the next exponent? 9. So Isaac, there are no grouping symbols, so no pet P. He did E for exponents, and now you're at the multiply or divide. So what do you get? Good job. So again, on some people's work, I've been saying, show your work, show your work, show your work. This is what I mean. All right, show your steps. Questions on that? So take a look at what's here. You're going to look for parentheses. There's none. So, Talisa, what would you do first?
Yeah.
Okay, and what do you get? 16. Anything else you want to do right away, or do you want to just write everything else down? Okay. So she did no grouping symbols, no no parentheses or anything like that. So she did her exponents. What would be next, Lisa?
And multiply 2 and 5 and 3
Okay, what do we get here?
4. 10
Okay. What's next?
and add.
So this is, again, where people mess up. You add and subtract left to right. So all that's left are adding and subtracting. So you are going to do these operations left to right. You don't add first and then subtract. Did you guys get that? It's different. You get a different answer. So if we add and subtract left to right, what do we get first, Talisa? -2. Yep, so you do 10 minus 12, that's -2, plus 16.
14.
Good job, Talisa. Is 14. All right, but if you were to add these first, you would get a different answer. Does everyone see that? Because if you add these first, you would get 28, and 10 minus 28 is -18. It's not the same answer. Right? Questions? So, showing your work, important. Okay, Brendan M., we're on you.
All right, so first you see that there's, well, it's divided, so there's brackets around the 7 minus 3 times 4.
Okay,
So you're gonna start with the multiplication,
all
and you're
right,
gonna get 12.
great.
And then you're gonna leave the brackets on that phrase. Yep, there.
Okay,
And now you're gonna do the 7 minus 12, and you're gonna get -5.
good.
And now you see that 2 negatives make it a positive, so it'd be 8. Because you do 3 plus 5.
So what do these symbols mean, these two vertical lines?
It's separated from the rest of the equation.
So that would be if it were parentheses, but the two vertical lines mean something very specific.
Oh, absolute value.
Right.
Sorry, so it'd be 5.
5,
So 3 minus 5.
which is
-2.
-2. Good job.
Thank you.
You're welcome. Questions?
I think Talisa is next.
Very funny.
I think I have.
Okay, so notice for this one, we have a grouping symbol within another grouping symbol. We have the parentheses, and then we have the absolute value sign. In the case that you have more than one, you're going to work from the inside out.
So
go ahead, Logan.
9 minus 5, which is 4. So then you got 3 minus 4, which is -1. And you get for the absolute value is 1. And
Do you want to do
absolute-
this one too? Do
Huh?
you want to do this one as well?
Well, wouldn't it just still be 3?
Yes.
Is that, wait, so that's, wait, so it's 2 times one, negative 2 times 1.
Did you follow what I did there? So I took away the absolute value sign, because as you said, the absolute value of -1 is 1.
Yeah.
So since the -2 was right on the outside of that, that indicates multiply. So I just put a little dot there for multiply.
So you do negative 2 minus times 1.
Right.
Negative 2.
Mm-hmm.
Then you get negative 6. Oh, no.
Just one away.
Negative 5.
Beautiful. All right, questions on that? Inside out. And the thing is with these is there's really no like, oh, this sounds right or sounds wrong. Some of these problems will really feel right or wrong. They'll all feel right even if you're doing them wrong. So it's going to be very important that you show work, check your work when you're done. So use a calculator only when there is a calculator icon near the problem. So if you guys can go ahead and get started.
Tomorrow.
Yep.
Oh my lord.
Time to have to work,
A lot of math.
still get it.
It's like one.
You have enough time to start.